Scientists in China who have experimented with materials to protect drones and missiles from laser attacks say they have come up with a surprising potential solution. Experiments show that common inexpensive resins hold promise in protecting such weapons from being damaged by laser weapons, scientists say. The material-coated sample remained intact after being detonated by a weapons-grade laser beam for 15 seconds at a power density of 500 watts per square cm, far more powerful than that needed to destroy an unprotected ballistic missile. The 3-megawatt laser weapon could theoretically intercept incoming missiles with a power density at the target of just 300 watts per square cm, according to scientists. The newest and most powerful lasers currently available to the U.S. military produce a beam of 300 kilowatts. Megawatt laser systems do not yet exist but are under development. In their experiment, the researchers applied a 2.5 mm or 0.1 inch layer made mostly of boron phenolic resin, BPR, a composite material widely used in hot, high-pressure environments. China is the largest BPR producer in the world, where one factory can produce hundreds of thousands of tons of BPR annually. BPR is also cheap. In recent years, the average price of resin has fallen by as much as 7 yuan, or $1 per kilogram, or 2.2 pounds, according to industry data in China. Turning an ordinary BPR into an anti-high-energy laser shielding layer required only a few modifications, according to the team led by Professor Gao Lihong of the Beijing Institute of Technology. The solution uses low-cost raw materials, simple manufacturing processes and has very high performance, Gao and his colleagues said in a peer-reviewed paper published in the Chinese-language journal Ordnance Materials Science and Engineering on May 17. Rapid developments in hypersonic weapons programs in China, Russia, North Korea, and more recently Iran have increased the risk to U.S. air defense systems. Russia claims to have destroyed many U.S. Patriot missile defense launchers with its Kinzhal hypersonic missile. The Pentagon has confirmed some damage. Admiral Michael Gilday, chief of U.S. Naval Operations, said the development of hypersonic weapons by America's adversaries had made laser weapons a top priority for the U.S. military. From a defensive standpoint, "We are focused on threats," he was quoted as saying by CNN during a public event in August. The U.S. Department of Defense is reportedly spending $1 billion a year on the development of laser weapons, difficult to intercept as they travel at 5 times the speed of sound or more, faster than most interceptors, and sometimes fly in unpredictable paths. Laser weapons are seen as a promising countermeasure because the focused laser beam travels at the speed of light. BPR is already used in many high-speed missiles and drones as a heat shield, according to Gao's team. But a beam of laser energy focused and powerful enough can burn a hole through a traditional BPR layer in just a few seconds, the team said. So Gao's team purchased several inorganic compounds, straight from the market, such as silicon carbide, zirconium dioxide, and carbon black nanopowder, and added them to the original resin. The result is a new composite that was tested under the code name BPR-1. Over time, white material appeared in the exfoliated areas of BPR-1, but the heat impact areas remained relatively intact with no obvious peeling or coating damage, the researchers said in the paper. After being exposed to the laser for 15 seconds, the BPR-1 coating exhibited a maximum back surface temperature of 230 degrees Celsius or 445 Fahrenheit, not hot enough to corrode most aerospace aluminum alloys, which have a minimum melting point of 400 degrees Celsius. Laboratory analysis of the blast area shows that many spherical particles have emerged and fused together at the bottom of the ablation hole. The researchers also found a molten glass-like material throughout the heat-affected zone. The particles and glass are likely created by the added compounds, which form a protective buffer that fills gaps in the resin to prevent further damage, the researchers said. The BPR-1 and other recent advances in shielding technology are pushing the directed energy arms race between the United States and China to new heights, according to a Beijing-based laser scientist. "Welcome to Star Wars 2.0, said the researcher, who asked not to be named due to the sensitivity of the technology. Can a single dollar of materials render billions of dollars worth of weapons technology useless? It's possible, but increased protection will also force laser scientists to further increase the power of the weapon, he said. China, for example, is developing a compact 10-gigawatt power source for aiming energy weapons. The condensed power source can be used to generate high-powered lasers or microwaves, weapons that can target not only missiles and aircraft, but also satellites in lower Earth orbit.